afternoon. Dipti Vachani from Intel. I'm the Vice President and General Manager of Strategy and Solutions Division inside of Intel in IoT. So you guys talked about getting rich and staying healthy. If this thing would work, I may be able to talk to you about how we're going to keep you alive. So at Intel and IoT, we really look at this market and this division from the standpoint of the impact we're making to society and to our customers. If you look worldwide, today, 92% of our population lives with bad air quality. And that is worldwide, not just in India, as most of us know, in China, but also in large parts of our population. And we work with our customers to create solutions. We recently released a Bosch air quality monitoring solution that allows our customers to scale and solve these world problems. Another area that we focus on is also the area of mobility for elderly, remote patient monitoring. So 16 million adults today over the age of 65 live in areas where they don't have access to quick transportation. And so autonomous vehicles, remote health care, those are areas of focus for us as we look at IoT. And so we've talked about IoT, and many of us think of, I think someone mentioned the Nest thermostat, which I'm very proud of. We talk about IoT and we think of those things we see in our home. Maybe we see the Echo. But when we look at IoT holistically, there is actually an impact to everything we do and how we live our lives, and that's holistically how we look at IoT as well. So when you look at IoT, you have to think about it in 3 phases, because there's an idea that IoT is everything we've been doing for a very long time. I'm going to get myself a shirt that says I was IoT before IoT was cool, because a lot of us have been doing IoT for many, many years, right? And what we've been doing is connecting the unconnected, right? We've been connecting devices that previously had no exposure to a larger breadth of data. And we connect those devices, we connect them into the cloud, and now we have access to data we haven't had before. But then that moves to the next phase, and we see as an evolution in that to where now it's smart and connected. So not only is it connected to something, but you see that even in your home. If you see the Nest thermostat, you see the Echo, you'll see that it starts with connecting, then it starts with making it smarter. You saw that evolution with your phone, between the flip phone to now what you have today in your hands. But then the last stage is where we move to autonomy. And that is once you've connected and you've actually made those devices smarter, then how do they become more autonomous? And the kind of problems that we have to solve in our industry for devices to become more autonomous is distinctly different than what we've had to solve with just connecting and making things smarter. So I'm going to spend a little bit of time talking about how is artificial intelligence driving more towards autonomy? How is security, how is that impacted by driving things autonomy? And what kind of compute do you need when you go towards autonomy? Because that's the evolution that we see in the industry. But keep in mind, as I talk about this in phases, that's not how our market works. Our market actually works to where one customer is actually in many phases all at once. And I'll give you a very, very easy example. If some of you guys have flown here, think about your airline. That plane is probably the most autonomous vehicle you've ever seen in your life, and it's been that way for quite some time. That is a beauty of electronics if you were to ever go on site and see what's happening. If you knew how old some of those silicon pieces that are inside that plane, you probably wouldn't get on it, but that's okay, I won't share that data. But again, that's autonomous. But when you land and your luggage comes to you, that's getting better, but half the time they have no idea where your luggage is, right? That's about as unconnected as we go, right? And so any company, any industry is going through many aspects of this at any given time, which is a complexity in the problem statement. Because you're talking about old data, new data, data that's coming in from different sources, that becomes really difficult to solve. And then now you add this whole other element of autonomy. And so I will talk about the ecosystem implications of having this kind of ecosystem happening all at once within our customers. So let's talk about artificial intelligence, because we have a room full of entrepreneurs, I hope. This area is what is driving that push into autonomy. When we have more artificial intelligence data so that we can actually make independent decisions, now we have the algorithms necessary to drive decisions at the edge. And just last year, Intel spent $1 billion in acquisitions in artificial intelligence. The increase in acquisition year on year in artificial intelligence was 55%. So it's an area which is booming and which is propelling us all forward into this world of artificial intelligence. I'll show you a video in a little while that talks about what one of our favorite companies, Hikvision, is doing in this space and moving us towards using artificial intelligence data and intelligence to drive to manufacturing efficiencies. And so the format on this slide looks really funny. I really apologize for that. I'm not sure how it got all messed up. But you just have to listen to me. Don't worry about the slides. I'll tell you what's on it. Don't worry. The greater than $4 billion of acquisitions were done last year in AI. So again, the magnitude and the impact to our economy of where this move to artificial autonomy is pushing artificial intelligence and what we're seeing across multiple industries. So it's one thing to say I'm saying it in one industry, which is industrial. Some of us understand that, or you see it in homes. You're seeing it systematically across multiple industries. Retail, somebody mentioned Amazon Go a while back. Think about what's happening with Amazon Go. For something like that to work, there's artificial intelligence, there's cameras everywhere, and there's compute at the edge. And so I'll talk a little bit, we know quite about what's happening at Amazon Go and what technologies are being used. That's an incredible manifestation of all of these components coming together. But that's one example. Happens in factories just the same. It's happening inside of buildings just the same. And this thing is also slow. Okay, so I'm going to talk about Hikvision. I was actually there in China just a month ago to watch how they were using artificial intelligence, cameras, compute at the edge to improve their manufacturing capabilities. I think do I need a click to roll the video, or is the video just going to roll? There we go.
Artificial intelligence technology is transformational and has started to be adopted and deployed into the real world in many different industries. Hikvision, the world's leading surveillance company and the leader of IP cameras, has accumulated more than 10 years deep experience in image processing, data storage, video analytics algorithm, cloud computing, big data technology, and now artificial intelligence. This background has enabled Hikvision to start deploying video AI technology into smart manufacturing. One of the driving forces behind smart manufacturing is smart vision. Enabled by Intel's high-performance and stable architecture, Hikvision's machine vision camera combines perfect image processing and high-speed algorithm execution to deliver fast, accurate information acquisition and identification to manufacturing processes. In the sorting process, Hikvision's industrial machine vision camera reads the barcode rapidly and logs the volume and weight information. It intelligently automates the sorting processing with a throughput of 20,000 orders of parcel per hour, therefore reducing the labor cost by 80%. In addition to smart vision, the Edge Intelligence System is the brain that keeps everything moving with fluidity, precision, and control. The Vision Master Platform runs the deep learning-based algorithm from multiple sources of the video inputs. And through coordination with various production management systems, enables a more autonomous manufacturing process. This includes product line monitoring, sorting, and warehousing. For example, real-time determines the task assignment for the carrying robot fleet and sends the optimized navigation route for robots to effectively move products to its corresponding location. The result is a seamless, efficient, and integrated system that enables robots to navigate products without interfering with each other.
So I was actually in China to see how these robots were working in factories, and it really does look exactly like the video shows. Sometimes when you see videos, you're not sure if it was done in in a video room. It isn't actually. This was not done in some sort of blue screened room. These robots is how equipment is moving around and inventory is sorted one side of a factory. And you think the word that they used was edge intelligence system. And so the question comes to, how much data, okay, there's a delay. How much data and how much analysis has to be done at the edge when something like that is done? And how much is done at the cloud? Because there's this idea that, and I started alluding to that at the beginning of the presentation, where we say connect the unconnected. So all the data goes to the cloud, decisions are made in the cloud, and that is by far, I am Intel, by far the most efficient way of making those decisions. But when we look at the amount of data we're talking about, even in something simple like a robot like that, and simple I mean that it's versus a car, it's simple in the relative terms, right? Think about a robot like that, the amount of data they're collecting. At this point, we're talking about 50% of IoT deployments will be bandwidth limited. You won't be able to get all that data to the cloud. So the decisions, at some point, it's just the bandwidth is restricted so that you cannot get the data to the cloud fast enough, and you can't make decisions fast enough. So as a result, we believe already 45% of the data has to be stored and processed at the edge. So why is that? One, I talked about it. First is the data can't get to the cloud fast enough. The pipe's just not big enough. Now 5G is absolutely going to help some of that. Latency is going to get better. The pipe's going to get faster and bigger. But in reality, our market and how fast it's moving, algorithms and data, how fast it's moving, is still going to make this problem worse year on year. So now we're talking about a world in which data has to be stored, processed, and understood at the edge. There's a couple of other things. So I talked about the pipe. There's a couple of other reasons why that data has to be stored, processed at the edge. The other one is latency. So in making decisions, in this case it was a robot, but think about a car. Think about manufacturing and robots that are doing safety critical activity inside of a factory. Now you're saying that latency is microsecond. I mean, you're talking very small latencies to be able to make those decisions at the edge, and the cloud just won't do it. No matter what kind of efficiency you get, there's just not enough. And the last thing that we hear often is privacy. So we have great security. Security is improving year on year, but still there's this element of privacy. I want my data to stay within the walls of the factory that I have, within the robots that I have. And so between privacy, between latency, and the pipe, all this data starts to move more towards the edge and into these compute vehicles that are at the edge. Now, with this data and the low latency that you have, you now can start to enable algorithms with artificial intelligence, not only in the cloud, but now in the thing, which is your edge intelligence system, as well as at the edge where you can start to move workloads around. Because when one vehicle itself starts to get overloaded, you can now move that data, move that algorithm into another one, and you can start to share that load along the way. And that's where autonomy and workload consolidation and the ability to move data and workload on from one entity to another starts to see its maximum value. And so, and pictures, this will try to demonstrate that. This is this idea that data is thrown into the cloud and analytics are in the cloud, and then what's really happening? This fallacy of everything going to the cloud, what's really happening is this new entity is being created at the edge. This is happening today. It's happening across the world. And in industries that I see it most, industrial and factories, they worry most about latency and they worry most about privacy. They don't want that data leaving their factories. I see it in retail. What they're worried about in retail is just the vast amount of data that's there, and then also privacy. Am I going to send my data to Amazon Cloud? Maybe I won't. Maybe I'll just keep it to where I am at the edge, right? Because I'm a retailer. think of autonomous vehicles. That's the most typical, easiest example to use because it's most intuitive to you, right? You can imagine if every data has to be stored and every decision has to go to the cloud, then that's not going to be realistic in a vehicle. So we see processing going up in the vehicle. So then, the ugly slide, that format's not working. The next thing that must come to mind is security. So you say, okay, great. Now you're having autonomous vehicles, you have data at the edge, you have components and robots working alone inside of a factory. That makes me incredibly vulnerable, right? How are we addressing the security problem? Security is, and again, I'm in a room full of entrepreneurs, growing at 20%, security and investments in security is going 20% year on year. The CAGR is incredible for the investments we're making in security, because I will say, standing here even as Intel, security is the #1 barrier for a lot of these deployments. And so what do we say, what are we looking at for security? We think security has to be at a platform-based and a hardware-based security. So you need to have many elements of security. It's done in your hardware, it's done in your software, it's done end-to-end in your ecosystem. So we're working across the industry to address those. We currently just released our threat detection technology that is silicon-based security. In addition, the slide is hard to read, but our partners are also doing the same. So you see Microchip and Amazon partnering together to release security solutions. And so we look at this security as we have to do our part in the silicon side, then we also work across the entire industry. Because when we solve this problem, we solve it industry-wide. And it's very much a #1 investment for us, and one we take very, very, very seriously. Okay, so another buzzword that we hear often when we hear about security and IoT and blockchain. And so I'm going to spend a little bit of time explaining why that's important in the context of everything I've already said. You've got workloads that are moving to the edge. You have items that are more consolidated. Workloads that may be moving from one item to another, so they're more independently making decisions. Not everything goes to a cloud for us to make a decision. So then this idea of the methodology of blockchain comes into play. And why is blockchain important? Well, blockchain, if you've heard of it, is pretty much a technology that was used so much for treasury and cryptology. But it is just a way to keep a ledger of security along the way, and one that everyone has access to, and it's accessible yet protected by all in the value chain. And for instances where you have inventory management, where you're looking at many items and everybody's got access to different amounts of data, blockchain starts to become a key component or security feature that we can use as these workloads start to distribute. So when you use the word distribute, workloads start to go across many different entities. Now you need to secure it differently than you would if one thing was just going to the cloud, because all you really care about is that secure channel between the thing and the cloud. Now you got to worry about the secure channel between the thing and the thing, which is where inventory management or factories come in play. And so we see that as an incredible technology, one with significant amount of investment, and that goes across everything we talked about. I know the conversation just before me was one about strawberries. And actually, strawberries was a very typical example used in ideas where you can keep secure data and inventory management in that industry, right? Healthcare is another one where it's really important for that data to be secured independently, patient by patient. I talked about this. With the slides going slow, I think I'm talking more faster than the slides are. So when we talk about the ecosystem, that was one I spoke about at the very beginning of the complexity of the ecosystem that creates IoT. So there is no one says I'm in the, you rarely hear it. No one of my customers will say I'm in the IoT business. What they say is I'm in the industrial business, or I do retail stores. And what I'm trying to do is create an autonomous store. Those are the perspectives that are coming from, and the ecosystem that has to come together around what their use case is in the application is security, cloud service providers. We come into hardware connections, and how are those connections made, and how do these fragmented things actually talk to each other, right? This isn't very odd when you look at an industry in its infancy and one that's developing like we are today, right? If you thought about maybe USB, you probably have a lot of things that connect up to USB. Your computer, your phone, pretty much anything you can imagine connects up to USB these days. That's because we created a connection that was universally used across the entire ecosystem, and then we all tied to it. IoT much more complex because there is no one market that you can look at the same way. But we have to start to create interoperability and work across the industry. So we create standards. So we're looking to create security standards, connectivity standards, so that these multiple things that we're talking about can actually come together. And if one application that's sitting on one entity moves to an application that wasn't created by that same person, can actually talk to one another and share data. So data is the number one problem because the data is odd when you look at it between the two entities, and be able to share workloads across others. And so there's many things that we have to make happen, and lots of ecosystem partners that has to come together for this entire value chain to come into play. One of the things that we look at in Intel is we create what's called market-ready solutions. And we work with the entire industry to say, to solve X problem, here are the 6 components that have to come together. And these 6 companies have to come together, and we work with an ISV as well, and say, this is how all the software is going to work. This is how each one of these entities are going to talk to each other. The Bosch Air Quality Monitor that I mentioned earlier, that's a market-ready solution. It's a sensor at the edge. Then there was some compute done at the edge. Then it was talking to the cloud. That data was going back and forth. There were cameras at the edge. Then that camera data was also taken into account. And we created a recipe and deployed it. Those market-ready solutions are valuable, and they work to enable to allow our customers to scale. But they're not enough. Because what did we do? We solved one use case. Great. And it does help our customers. But what we need to do in addition to that is work across the industry. And that's where we talk about consortiums and creating standards. So we have an open fog consortium that we work on. This is the edge compute technology. How do you create an entity at the edge? How do those workloads sit? How can a developer write an application that sits on that entity? And then how is it universally used, right? We can do the same thing when we look at interconnectivity, so connectivity at the edge, and how's that data captured, how's that data stored. So those have to be created, the standards need to be created around that as well. And so as we say, IoT is a team sport. It really doesn't come down to any one company, any one entity that can truly bring all of those pieces together and make it work and scale. Those are partnerships that we have to create. Those are industry standards that we have to create. And you would be, if you looked across the companies, you can see some of their names on here. Partnerships with ARM and Intel, which maybe about 10 years ago, that would have been a hard one to swallow, right? Partnerships between, you've got Microsoft, ARM, Intel, and Dell all coming together, right, to help with the Open Fog Consortium. You'll see Samsung, it's not listed on here. I know Samsung and Intel working with the government to start to create standards across all of our cities so that we can start to work through deployments in cities. So it's an incredible time and place where you see multiple entities coming together, massive companies, because we really believe that through these consortiums and standards, we're actually making the pie bigger. We're actually making everything bigger for everyone. And then we want our unfair share of the pie, obviously, every one of us do. And that's fine. I think it makes the best answer for our consumers because everybody's wanting their unfair share of the pie. But as we start to do that, that's when the market starts to scale. Because otherwise, you've got no scale today. Everything is hodgepodge. We've had the IoT group inside of Intel now. I think it'll be going on about 4 to 5 years now, about so. When we first started, we call it the POC machine. we could create great proof of concepts. And they're beautiful, right? You walk into a conference room and there'll be this beautiful proof of concept and it'll show you how it works. Put it in a factory, see what happens, it blows up, right? Because not everything can connect and the data doesn't talk to each other. It works great in a conference room. And now we've got to take it out of the conference room into factories. That's market-ready solutions. That's the step into putting into factories. And then from factories to wide-scale deployments, that's when you need standards and symposiums. So imagine the possibilities with IoT working across all industries. This is the first time in my entire career that I've seen multiple industries transforming all at once. It truly is a special time in our world, in the space that we work in. We can see for myself technologies that go into retail, into cars, into industrial, they're exactly the same technologies. They're solving the exact same problems, but they're in different markets all in all. I've never seen I've been in the industrial market for quite some time. I've never seen those guys move so fast. Because if you've ever worked in the industrial market, you know how slow those guys can be. This is the fastest I've seen that market move and the innovation happening in that space. Retail, we all talk about, gosh, brick and mortar's going away. Why would you even worry about retail? Well, one of the biggest motivation of moving fast and doing things innovative is you think you're going to die, right? And that's a motivator to want to do things differently. And you see all these wonderful ideas like Amazon Go. You'll be surprised at the amount of autonomous Amazon Go-like stores in China in the next couple years. It's going to happen fast. You'll see it in China immediately, then you'll start to see more in the US, and you'll see it going across our market. So are the number of stores going up? I don't know. I'm sure there's data that says yes or no, but that's not the point. The point is the number of compute, cameras, and data, that's going up. And that's what problem we can solve with IoT. Okay, and then I have to do this. I have to, I have two little girls. I know it's 4 o'clock in the afternoon, so it's nice to make it a little bit more relaxed. I have two little girls, and one of my girls told me that if she felt like if she didn't read the legal notice at the end of everything, that somebody would catch her. So she actually, until very recently, actually read every one of the legal notices. I was like, sweetie, no one's going to catch you. There's no camera watching you. Maybe I'll figure out a way to get a camera to watch you all the time. But right now, you don't have to read every line of this legal notice. Okay, where are we with time? I can't tell. I'm done? 2 minutes? Okay, well then.
Well, on that Amazon Go part.
You asked the Amazon Go question. You got my mind going.
What you know more?
Say that again?
What you know more about the Amazon Go and Intel maybe, or?
Well, no, I'm not going to talk about Intel and Amazon Go, but I will talk about, think about the technology that's required for something like that. Inventory management, cameras, artificial intelligence, computer vision, compute at the edge, and data analytics and the cloud. So this is all of these technologies. It's a beautiful example of all of these technologies coming together to provide a very real use case that you and I can see and see the difference of and the impact of. And what I will tell you, I won't name names, but I will tell you this is not the first. It's happening in large scale across many different countries, and one I already alluded to. So,
where in China did you say?
I just said China. No. It's a big country.
I have a question about the trend I'm seeing is cloud computing, fog, and the edge. Mm-hmm. So there is a lot of work done on edge computing, edge analytics, and pushing the boundary all the way towards the sensors. Mm-hmm. What is your thought, and what do you see next after the edge computing?
So I think we got a whirls to go with edge computing, artificial intelligence, and I think today the number one trend we're seeing in all of these is cameras, vision. So we see vision everywhere. It's going into everything. It's going into factories. The way that high vision robot does what it does is because it has vision. right? So eyes. But I think that's just the start. I think we'll become ubiquitous, that there'll be vision everywhere. There's vision in your street lamps, if you didn't know that. They're happening, and Intel's a part of that. So there's vision in your street lamps, there's vision in everywhere we go. So the cameras are coming. But that's just going to become ubiquitous. I think that's a phase. And once we see it everywhere, it'll continue to happen, but it's not going to be as earth-shattering as it is. Then the next phase, and this is an opinion, is more going to come into real-time, really, really low latency decision-making, which that vision enables us to do. We're not there yet in how quick we could make decisions and the amount of data we can gather and how quickly we can synthesize that data and use artificial intelligence to make decisions. That's when things actually truly become autonomous. And our cars are starting to do that, right? You see that in our cars. But that market is just on the brink of exploding in everything, beyond just the cars. The ability to make real-time decisions at the edge. Yes?
This may be a little bit mundane, but consider.
I do mundane all day long,
Do you?
actually. I don't get to do all this cool stuff every day.
Unfortunately, didn't leave it at the office.
Yeah.
How about the energy problem for these remote disconnected devices, especially vision type things, a camera and to transmit any kind of data? You need some power, and what if you don't have power available right there? How do you deal with it?
That's an interesting question, and it's one where we're partnering in the industry to solve for, and not one that we have a complete answer to. Today, we're tying into things that already have energy. So think about light bulbs. So I think the first step is not to try to solve necessarily the energy problem, but more look at what do we already provide energy to, and how can we make it more robust. So you think about a big street sign that you may see I was just in New York, in Times Square. You see a big, huge screen. What I see is a server. I see the ability to put large amounts of data and camera and server. So could that be my big energy hub of data compute? And then I can distribute sensors in the city, and that's my hub for a smart city. You didn't know it. You thought you had a big, pretty screen. What's really happening behind the scenes, because I already have the energy, is your servers being computed and all the other smart city activities going through there. So that's how we're looking at it right now, because we don't have the perfect answer. I'm sure someone will come up with something really cool, and it's going to be in this room, and they're going to be a billionaire. And I want a piece of it because I had something to do with it, I think.
Thank you.
One more question.
Yeah, so you mentioned actually 45% of the data are processed at the edge, right? So, and the rest, almost like 55% at the cloud. So which factor decides, so which data to be processed at the edge, and which needs to be transferred to the cloud?
It's a very hard question that you're asking. So it sounds like it's a simple question, and it's not. And part of what makes that question difficult is a lot of folks that are deploying these aren't the experts on data and technology. These are industries that in previous didn't have the best in technology in the world. And so that's why it makes it hard for our customers to decide. So I acknowledge the difficulty of it. But what factors decide? One is, what data do I need for real-time decision making, okay? So that data has to stay at the edge, because I don't have time to go to the cloud and come back to the edge. So what data do I need? And often, if I just want to see, if I'm a camera and I want to know that that's a cat, and I want to store that in the cloud and said it's a cat, I don't need that for real-time decision making. I can keep that data. I don't need it at the edge. So what is it necessary for real-time decision making? That's number one. Number two, what data is private to me? Is it healthcare data that I want to secure in an entity that I have physical control over? That'll determine some data that you'll keep at the edge. And very often what you're going to keep at the edge, more than data, is the insights that comes from that data. So maybe what's in the cloud is what helps you create that insights, patterns, things of that sort. And then the decision, okay, you saw 5 cats in a row, may stay inside of that edge to be able to make decisions in the end. But it's I'm waffling. I can't give you a formula because there is no formula, right?
Okay. So actually, it should have that kind of intelligence to decide.
Yes. Thank you
thank
so
you
much.
very
Thank
much.
you for having me.
Thank you.